Ladies and gentlemen, good afternoon. I am James Cook and welcome to the last session of the Land Warfare Conference, and I'd like to say congratulations for making it this far. Well done for sticking with it, but you're going to finish on the highlight. Absolutely. This will be the best panel, and I think you'll agree is the best looking panel by far. On that side anyway. I'd like to commend to you the opening article in this British Army Review written by our Director of Capability, Major General Chris Tickell, that links in our innovation approach and adaptability with what happened 75 years ago and his reference to Hobart's funnies. But the point he does make is that innovation takes motivation. And the motivation of a total war, you get to play risks with lives and money. And that's very important when you look at motivation for this subject. But now we're going to do something that will probably terrify you, and we're going to do some audience participation to make sure you're still awake and not looking at your iPhones. Everybody looked up, thank you very much. I'd like to ask the audience, what is the most difficult and complex physical terrain we will soldier in as of now? Urban, thank you very much, you're correct. If we want to fight and compete in the urban, whether it's above or below the threshold, I suppose if we're in the urban it's probably above, what key capability would Western armies want that they probably haven't got now? I understand this is probably going to be a wider answer, and let's just say it's not command and control. Napalm probably a little bit on the extreme, but I like where you're going, Peter. But I'm not disagreeing, that's not where I'm going. You've got to get to the right answer. Mass. Thank you, Brigadier. It's a cracking answer, but wrong. No, not this one. That would be another great... This is going to take some time, isn't it? Because it's not the answer I'm looking for. Sorry, did someone say firepower? Thank you very much. That is the correct answer we'll go for. So we've decided, without any influence from me, that the urban and firepower are required. So we need to innovate. What's that? With thanks to BAE, can anybody tell me what that is? Specifically what it's made from? That is a Challenger 2 body and a Warrior turret. And because BAE Systems own the intellectual property rights of both, they can put them together. And our Secretary of State for Defence yesterday said that we have to stick to the headmark of STSR-10. And within that headmark, we have to dispose of some of these. And when we dispose of them, it costs us money. It's actually cheaper to put them together. And you end up with a crazy, and on the cookie crazy scale, it's out there, but you end up with a heavily armoured, but very mobile, because you've taken off about 12 tons, fire support platform that can elevate to 45 degrees. I think the majority of combat elements in this room would agree that would be quite nice to have in the dense urban. If you're of that ilk, could you nod? Or not? Okay. So my challenge to you is, how would we, the British Army, get into putting something together that BAE can do for us, that we have, that would cost us less than it would cost us to dispose of? Or we can spend more money throwing them away. That would take a truly innovative approach. And that's what this session is going to get into, once people have stopped staring at me as though I'm a lunatic. To answer this question, we have the obviously best-looking panel. On my right, your left, Lieutenant Colonel Al Brown, the commanding officer of 101 Regiment Royal Engineers, who is better known to the British Army for his excellent work at DCDC on AI and man-unmanned teaming. On my immediate left, your right, Sam Bendett, a research and analyst from the Center of Naval Analysis, a Russian expert and linguist, and a huge capability in AI and Russia's robotic systems. And on my far left, Professor Nina Kollars, Associate Professor at the American Naval War College and Cyber and Innovation Policy Institute. It is our challenge to them, on your behalf, to get into the question of how would we go about innovating like that, when at this moment in time, we don't have the motivation that our forebears 75 years ago had. Al, the floor is yours for the next 10 minutes.
Thank you. Innovation is clearly not technology, but Rusi have invited me to come down and talk about technology. People struggle with artificial intelligence, which is why they've asked me to talk about that, and there's a reason that people do. It simultaneously confounds expert predictions and arrives at milestones far faster than anyone anticipated, and yet at the same time, it sits at the top of the Gartner hype curve, so it's better and worse than we expect at the same time. So who's prospered? Who has managed to innovate with these things? Well, if you're looking across out into the commercial world, you can find some great examples, and you can also draw some lessons from that. And I would say that one of the first things you can look at is have a look at Amazon. So one of the world's most wealthy companies and are recognized as an internet company. And you immediately go, well, an internet company we know isn't a shop with a website. So what factors and attributes have they managed to exploit that have given them advantages over others? And studying them, some of the examples that come out are they do pervasive A/B testing. They have really short cycle timelines. And fundamentally to do that, they push decisions down to project managers. Now that sounds great, but it actually happens to you. So what does A/B testing look like? So when you're watching Netflix, Netflix is watching you. So you will get all these tiles that turn up. They're tailored to you. They are designed to drag your attention in, and you get a specific tile that is designed to capture what Netflix thinks you are. And the way that happens with A/B testing is they take a like-minded group of people, they split it down the center, they give half of them algorithm A, half of them algorithm B. It tries to work out which draws the most attention. The most successful algorithm is retained, and the other algorithm is discarded. The successful algorithm doesn't stop there. They take it, split it again, mutate it a little bit, and they repeat it in this Darwinian cycle. So you have an engine that is designed to find your attention span. It's optimized, and that is A/B testing. And the cycle speed they do that with is why they get those phenomenal advantages over lots of other conventional forms of advertising. Cycle speed is going to really matter when you start to think about artificial intelligence. So this is a great example. This is AlphaZero. So one of the successors to AlphaGo, and it got to the point where it was a grandmaster at chess after 4 hours, starting only with the rules of chess, which is an incredible technological achievement. But it's important to understand what cycle speeds mean in terms of the limitations and capabilities of artificial intelligence, because it played itself. If it had played a human, it would have got about 10 games in, consequently would have developed a relatively poor database against which to learn, and would be pretty rubbish at playing chess. But by playing at machine speed, it's able to develop what we think of as phenomenal capabilities. How do you transplant that across to a more military background? Well, this is Tom Cruise dying a lot. That's always nice to look at of an afternoon. It's from a film called The Edge of Tomorrow, and it's kind of Groundhog Day meets D-Day. He fights the same battle again and again and again and again. And at the beginning of the movie, he is rubbish. And by the end of it, he is a positive ninja at this battle. Now, we know that we never fight the same battle twice, so there's one limitation there. But there are some battles where it is more appropriate or more realistic to have surrogates or simulations. So there is already a piece of computer software that consistently wins at high altitude dogfighting with combat aircraft and beats Top Gun pilots, because that is just maths and you can simulate it in the same way as the chess match. If you were to try and do the same thing with an insurgency, your ability to have a feedback loop that presented you with a realistic surrogate is likely to be far more difficult and is therefore a long way off. Computers also learning systems, machine learning systems, particularly reinforcement, tend to do exactly what you ask them to do. So this creature here was designed by an algorithm, and it was given the task of creating a life form with a set amount of biomass that could jump to a certain height. And you look at it and that looks pretty rubbish. But then you have to realize how the conversation, the codification goes with the computer. So you say to the machine it doesn't understand, so you say, well, what's jumping? Well, jumping is how high you can get your feet off the floor. What are feet? They're the bits that start on the floor. And suddenly that actually looks like a really creative, innovative way to pass that test. So it's passed exactly the test that you have optimized it for. There are other models, so you have data-driven models rather than reinforcement learning models, so much like the classic picture recognition system, and they are data-driven, so they are really good at interpolation but bad at extrapolation. What does that mean? So let's say this is millions of dots that represent kittens and pictures. If you ask it a question about kittens, it could probably give you a superhuman answer. If you ask it to go outside that data set and say, tell me about tigers, they're like kittens, it will probably fail miserably. We are constantly exhorted to think outside of the box, but as we're using some of these tools and they get more advanced, you're going to have to think about the box. And why is that going to matter? Because everything outside the box is incredibly, well, typically it's context. And if you were to ask yourself how often context can change the data that you receive and what you should do about it as an appropriate action, I would just point you to these two pictures here. And I would say that codification is going to be one of the things that we have to consider increasingly when we're looking at these tools and how we exploit them. And there are no simple, easy answers. So if you think it's difficult for a human and it's going to be difficult for a machine, that picture tells you an amazing story. The pilot is typically paid a lot more. The pilot will definitely tell you he's more skilled. And at the same time, if you were to look into the aircraft industry, all he is doing is maths and physics, which can be codified, which is why the man on one side is an autopilot, and the person who has to deal with all the imponderable, uncodifiable aspects, like who really ordered the vegetarian meal, why is the child being an arse. It means it can't be codified well, and it's likely to retain human capability. It's likely to be the realm of human for some considerable time to come. So that's all very well because it feels a bit businessy. So let's have a story about life and death, which will probably excite a military audience. It's going to depress you, though, because it's a story about lettuce. So at Stanford University, there were a couple of students who, of a weekend, would go out and they would take pictures of lettuce with their iPhones. And what they then did was they took that away and they gave it to people who could codify whether this was a healthy lettuce, a lettuce with a disease that would transfer to other lettuce, or a weed of some kind. And then they gave it to people to classify, I imagine on some sort of swipe left, swipe right, vegetable version of Tinder. And that gave them a big, nice data set of what a good lettuce and a bad lettuce looked like. They then created a machine that was dragged behind a tractor that looked down at the lettuce and shot exactly and only the weeds and the diseased lettuce. And the advantage for the farmers was that they didn't have to buy tons and tons of insecticides or pesticides. So there was a net saving there. They also got loads of bio credentials for their lettuces. But that's not the end of the story, because that wouldn't have been a defensible business model, because what the machine also did was it took more pictures of lettuce as it went along, which they were able to refine, and it creates this kind of virtuous cycle, which is starting to appear in more and more artificial intelligence companies. So you need the data that gives you the tool for the job you want to do, which you then get to users who want to use the tool, and in using it, they create you more data. And again, this happens to you. Have any of you recently been onto a website where you've been asked to prove you're not a robot? Someone will have been paid to provide that service to that website. So the vendor, A, is paying vendor B, provider of this system, for that service. But you are also helping vendor B, because at the same time as you are labeling data or proving you're not a robot, if you've seen a lot on cars and street signs, do you think Tesla pays good money for this? So that kind of multi-move game of chess about data acquisition is one of the things that is defining what an artificial intelligence company is likely to be. And AI companies are not going to be the same as website companies with a bit of machine learning, in the same way as an internet company is not the same as a website with a shop. There are two other factors that are likely to or hold true for some of the big four that are proving to be the best at artificial intelligence, and they are the ability to chase pervasive automation and also to push decision-making down to project managers. And one of the reasons, and I can give you an example here as to why you need to push decision-making down to successfully achieve this, is that the pragmatic details really matter. So here's a really old example of someone attempting to create a robot tank. That system's only ever going to work once you can answer all of the pragmatic questions, including some of the slightly non-technological ones, like who cleans the barrel of the weapon? Who does the driver A jobs? Until you can work out your perfect human and machine optimization, you're not going to get to the answers for some of these. Because details are difficult and we don't like them and they don't work in big abstract forums like this, we tend to have go-to discussions. I would just say that if you're in a project and someone presents you with one of these and the answers are, we will never under any circumstances, or we will always in all cases, it's always worth chasing to the bottom of bedrock, because that's probably not true, and you'll probably find it's a bit more complicated or a bit more specific than that. And you don't have to answer all the questions or have the highest technology to succeed. So people are using automation without any form of machine learning and achieving incredible results. I would also cite there is a case where General Perkins was talking about a $200 drone that was used in the Yemen and was shot down by a $2 million Patriot missile. Frank Hoffman would describe that as a strategy sin and encourage you to go out and buy as many $200 drones as possible, because even if they all get shot down, your opponent is hemorrhaging money like nobody's business. And I would say that another way of thinking about that is that if I had not said Patriot but said S-400, you might start to think about some of these tools in different ways. The final point I'll leave you with is that no country or industry has a monopoly on this, so we've heard about it being civil-led, so that means that no one is doomed to be behind. It will simply be those that are adaptable and innovative who will take advantage the best.
Al, thank you very much. I wasn't expected, and nor should you be quoted on vegetable version of Tinder, which is not the thing that stuck in my mind. But I think a very articulate approach to the benefits and the rationale and the reasoning behind how we might exploit AI and algorithms. Thank you very much. Now it's over to Sam, who's going to talk to us about Russia, their systems, their approach to innovation, and I think some of the experience of Syria over the last few years.
Thank you, James. Apologize for the quality of my voice. I caught a British cold on the way here, so thank you very much. Just a few words about my organization. CNA is a federally funded research and development center. We work mostly for the Department of Navy, but we also work with other components within the U.S. Department of Defense. My Russia team, where I work, looks at unclassified open source data, of which there's plenty. And we work on a variety of topics, including Russian military modernization, military-industrial complex, as well as how Russians make decisions in crises and based on the things that are in front of them. Today I was asked to discuss Russian unmanned systems developments based on Syria going forward. A lot has been written and said about it, and I just want to highlight the main points. Syria, to the Russians today, are the contours of the future war. So the combination of unmanned and robotics with information operations, with the precision-guided munitions, special forces, proxy forces, and kind of everything united together for a common goal. Russians saw what the Americans were able to do in Syria. They tried to copy some, and they tried to innovate in other areas, using their own unique capabilities and their own unique military characteristics. But Syria looms large. It's probably the biggest watershed for the Russian military, starting with the advent of military reform back in 2008 and 2009. The MOD, the Russian Ministry of Defense, knows very well it has to innovate. It understands it doesn't have enough money, or it doesn't have as much money as the United States or even China, so it's looking for a breakthrough. It's looking for that one specific innovation that will put them over the top or leapfrog existing capabilities. But innovation doesn't happen in a vacuum. Innovation requires institutional flexibility. And so over the past decade, rather 7 years or so, we see the Russian Ministry of Defense launch new centers, new capability shops dealing with unmanned systems, robotic, artificial intelligence. We also saw them launch their own DARPA, Advanced Research Foundation or Fond Perspektivных Исследований. So the ARF has the similar mission to the American equivalent. And it too is looking at innovation. It too is doing a lot of interesting experiments with breakthrough and new technologies. It has a limited budget, but it's not stopping them from doing some very cool stuff. So what have the Russians done in Syria when it comes to unmanned systems? Given the scope of this conference, I will concentrate specifically on the land systems. On the upper left corner is the Uran-9 military robot. A lot has been written about its so-called failures in Syria, and of course, what do you do with a new technology if you have the capability? You take it to a crisis area. For Russians, Syria became this innovation space, objectively speaking, cynically speaking maybe, where they tested over several hundred technologies. They rotated their best and brightest soldiers, generals and officers through it. So of course it came as no surprise that all of their new technologies also got a chance to be rotated through Syria. And Uran-9, the largest and the biggest Russian UGV, unmanned ground vehicle, the tip of their spear, unfortunately for them, failed. And it failed across probably every single aspect. So it failed in locomotion, high-tech electronics, it failed in firing mechanisms, it failed in situational awareness, and the Russians kind of took it back and decided to work on that. Russians also were able to test Saratnik UGV, which is the bottom right corner, which is a mid-size UGV. Not much is known about the results of that test, except the fact that they were tested in near combat condition and in temperatures approximating those of Syrian deserts. But Russians were also very successful with using smaller situational awareness tools like the Scarab, which is the center picture on the right, and the Sfera, little UGVs. These are small technologies equivalent to those in service with the Americans, the Brits, Israelis, and other countries. Also, one of the biggest successes was their remote-controlled demining UGV, Uran-6. That's the upper right image. Every time you Google a phrase Russian robots in Syria, you usually get a picture of an operator with Uran-6 or Uran-9 somewhere on trials. So Russians understood that some stuff actually works, and they also understood that they have to build on that. And I'll get to the Uran-9's failure in a few seconds. The bottom center picture is that of a Nerechta UGV. It's a small, mid-sized unmanned vehicle. ARF, the Advanced Research Foundation, is using that as a test bed for manned-unmanned teaming, for teaming with other unmanned systems, and even supposedly using AI as well. And also, according to the Russian government, Uran-6, Sfera, and Scarab are going to be accepted into service. So the use of these technologies in Syria prompted the MOD to think ahead, to learn from their unique experience there, and to experiment with a range of UGV designs and applications. And so I have several images in the preceding 2 slides dealing with that. So Uran-9 was taken back. Russians very publicly deconstructed their experience there. And there were 2 problems. Problem number 1 was that they understood that such a vehicle could be used in breaching operations or in one-off operations, because it was a remote control vehicle. It couldn't think for itself. Therefore, it could be sent on a one sort of robot mission. Another problem was that the operator couldn't quite understand what was happening on his monitors. In other words, he or she saw maybe half or 60% of the operational environment. And so if such a vehicle would be endowed with a automated control system capable of orienting itself in a fog of war or fog of the city or any other unplanned environment like urban combat, perhaps this vehicle would be more successful. And so the Kalashnikov Design Bureau that's taken over the project admitted that many failures experienced in Syria were actually solved, and that the vehicle will be accepted into military service soon. And they pivoted away from their failure in Syria by calling Uran-9 experience as a test bed for future operations. So they publicly stated that Uran-9 is not the final product, that more will be built on top of that UGV going forward. Russian defense industry today is developing many support and logistic UGVs of all sizes, much like their American counterparts. But perhaps influenced by Syrian combat and maybe even by the Uran-9 experience, Russian defense sector is working on a heavy UGV for urban combat. And so the bottom center and the bottom right image is that of a Sturm UGV built on a T-72 chassis, which is the most widespread tank in the Russian service today. It is specifically reinforced for urban combat. It's supposed to come in 3 varieties, so there will be 3 UGVs operating in concert. MOD is testing even larger and heavier UGVs like Vichir based on the BMP-3 chassis. Today, actually yesterday, they announced that it will probably be renamed from Vichir to Paladin, and Paladin would be shown at the Army 2019 Military Expo later this month. The MOD is seeking to better integrate the soldier and the machine in future combat. So the ARF is experimenting with lots of UGV design, lots of designs. One of them is called the Marker. And so Marker, according to the ARF, is basically designed to work in pair with a fighter, so that a UGV is receiving target designation from the side of the soldier's weapon, or it could be controlled remotely. ARF clearly sees the Marker as a learning tool, saying that the evolution of combat robots is on the path of increasing the ability to perform tasks in autonomous mode with a gradual reduction in the role of an operator. Russian defense sector is also experimenting with augmenting its ground soldier capabilities with exoskeletons. According to the official MOD announcements, Ratnik 3 and Ratnik 4, the 3rd and a 4th generation of the personal combat gear, will feature active skeletons, and soldier will be equipped with his or her own UAVs, UGVs, and supposedly all of that may be even powered by artificial intelligence to make most of the optimal information that the soldier receives and generates. But also, across the Russian military today, one of the interesting themes is robotization or automation. And so many current manned systems are discussed as potential robotic complexes. And according to the MOD, the numerous systems already feature various degrees of automation or robotization, so the next step, making them more autonomous, is a logical process. And these include the Armata T-14 tank that Russians are just rolling out, automating the T-90 tank, automating the self-propelled artillery systems, multiple launched rocket systems, howitzers, and many other technologies in use today. But the lessons of Syria dominate, and the defining characteristic of the machines tested there was that they were all remote controlled by soldiers, often in very near proximity to combat itself. So the solution, therefore, is to endowing these UGVs with more independent decision-making in the fog of war via an intelligent command and control system that may exponentially increase their combat effectiveness. So MOD has announced that its research and development community are thinking through the next set of requirements for their UGV development. And amongst them are requirements to solve tasks in combat conditions, for example, in day and night, under enemy fire, under electronic and informational counteraction, and many other aspects that UGV will be experiencing. So a major future UGV requirement for the MOD is modularity and multifunctionality. Another key requirement would be the unmanned system's ability to independently perform tasks in conditions of ambiguity. In other words, implying the use of some form of limited or larger artificial intelligence. So to achieve these requirements, the creation of an intelligent decision-making system is proposed by the MOD, which will also supervise the use of weapons. So in the near future, the MOD is planning to initiate work aimed at providing technical support for solving the problem set that I just described. One of the main requirements is the ability of the robot to communicate with the operators at a great distance in unstable communications climate. So are there any prototypes today that can point to where the Russians are going? There have been announcements in the open sources, and one of the more interesting tasks at my job is to actually identify whether this open source announcement speaks the truth, or whether it's PR, or whether there's some embellishment, or whether it should be discarded. So the Kalashnikov Design Bureau, that is now working on a lot of unmanned systems, has advertised its combat module that supposedly works on neural nets and supposedly can self-identify the targets. Another prototype has been announced by a civilian agency, which is basically a civilian guard system made up of many small UGVs that operate in an intelligent swarm. So whether lethal or non-lethal UGVs are developed in the near future, their defining characteristic would be the man-in-the-loop approach, for now at least, where a human operator is supposed to make the final kill decision. How that will actually work in the fast-paced combat environment remains unclear. But many issues still remain, and these issues are probably common, not just for the Russians, but also for the US, Israelis, Chinese, and many other countries working on unmanned systems. Specifically with UGVs is, how do we integrate these machines with manned formations? What are the logistics of using them in combat? What about the culture issues? Russia has the cult of the tank. And so many are convinced in Russia that no intelligent automated system powering a UGV can be as effective as a well-trained tank crew. The costs of all these systems is also a big question, and many other issues. But what's clear is that the Russian MOD is willing to experiment with a wide range of ideas and approaches, something we haven't seen before. Some solutions are entering service, others are still years away. The MOD wants to make sure that the warfighters also have a chance to weigh in on the system designs. So this is not an easy process, but at the very least, Russian MOD seems to be open to feedback. I'd like to thank Rusi for the opportunity to address you all and to discuss this topic. I'm looking forward to your questions and comments.
Sam, thank you very much. I'm rather taken by your description of Uran 9, Uran 6, and how it relates to yesterday's prototype warfare, in that Russia, the pacing threat in Europe, is actually delivering prototype warfare, maybe slightly ahead of us. And also more worrying, the fact that they're developing the second generation and the modularity approach, something obviously we need to get after, which leads us seamlessly into Professor Nina and her view on such thoughts. Professor, the floor is yours.
Thank you. I appreciate this. I'm not going to take the lectern, if that's all right. I'd prefer just to sit. So I want to echo some of the thoughts and ideas of my colleagues that came before me in just looking at the technological capability, and to just refresh in your minds that as we see the examples of these different kinds of machines or the possibilities of crowdsourcing, we actually have to get to implementation before we can try and figure out what this actually means for what warfighting looks like. Most of my work is on what if you give this capability to a person on the battlefield, how does that actually play out, and what does that mean for innovation actually on the battlefield? This conference has been fantastic, one, because it's reassured me that the conversations I've heard in this room over the past day and a half are roughly the same conversations I've heard in the United States. So that's reassuring that we're doing the amount of communicating and signaling that we should. The thing that worries me about these conversations is that they're remarkably imprecise, and we're all making guesses into how this is actually going to work. We're looking at proofs of concept, not actual implementation, and so we actually don't have any idea. And anybody who wants to sit in front of you and say, I know what AI warfare looks like, is probably lying to you. So you need to start thinking about, how does this actually play out? And I think anyone who is responsible is going to talk to you about what that looks like. There are a series of unchallenged assumptions about the application of new capabilities on the battlefield, and anyone who's been on the battlefield knows this. I can give you a machine, and whether or not you decide to use it is almost entirely up to you, and how you use it is almost entirely up to you. So what I would like to do in these last closing comments is talk about 4 unchallenged assumptions and its relationship to actually being able to innovate while you're on the battlefield. So one of the unchallenged assumptions as we go through these AI and automation conversations is when we talk about command and control. And we don't seem to challenge the assumption that we seem to suggest that we know where all the decision spaces are and we know who makes them. So in practice, when it comes to battle, whether you're talking C2, C3, C4SI, whatever acronym you want to put on it, I'm pretty certain that we actually don't know where all the decision spaces are in our own services when it comes to just pure targeting and delivering lethal force. And so you would do well. So say, for instance, I'm in a future imaginary operations center, and I'm tracking the approach of several targets, unknown actors, threats. So it's easy to say that we could apply AI to that, and it would effectively coordinate among those targets and generate a plan of attack and maybe also a plan of defense. That's in theory, right? In practice, for any of you who've had to do this, the decision architecture of that data environment is not just really hard to figure out because you're working across forces with coalition partners, but it's also contingent upon the terrain that you're operating on, your adversary's terrain, how you're gathering data. And so you want to think about, is it really the case that this AI is going to be able to be constructed? It's going to be really hard to construct this AI to do this because we don't actually know what sensors we're going to need at the outset. We don't actually know, in most cases when we talk about battle management, where in that decision chain somebody is literally handwriting a report, turning around and typing it into a system. If you manage to get that actual architecture structured out and look at it, it's probably going to change in the next campaign or battle or model you're playing with. And so the notion that you can have stability is a false one. So you either want to create an AI that can sort of take patterns and apply them without knowing the exact decision structure, which is dangerous and scary, so please don't do that. Or you simply will have to press downward and make smaller the kinds of artificial intelligence you're making. So what does this mean? If we don't know all the decisions on the battle space that we're going to have to do prior to going in, what we're going to see for innovation is that the degree and saturation of those systems is at best going to be piecemeal and amplify existing systems rather than being truly revolutionary. I'm okay with that, but you need to know that at the outset, because I think if you look at too many of these slides behind us, you will notice that there are never any humans on the slide, right? These are human systems. There's people connecting things together. There are people inside those tanks or walking beside those tanks. There are people in those airplanes or working back remotely, but there are humans, and you don't see them on the slide because we actually don't know what that decision space is. If we map it, maybe we'll get there. The second untested assumption or unchallenged assumption is that we can build these capabilities and the humans will adapt to them. And I find that one fascinating. My bet, historically, is that humans will use the machine in ways that are familiar to them, not how you want them to use them. And that's that innovative capacity of your user. So the question is, as we design these machines, are we simultaneously thinking about the profile of our future practitioner? Have we any plans for growing or developing them? So as a case and as an example, I just came back from a hacking conference, and we had spent all night playing pinball, as you do at a hacking conference. And the people playing pinball were all expert pinball players, which is great. And so many of us advanced up and down the ranks in competition playing pinball based on our expertise as users. And then at the end of the night, when we had all gotten so exhausted playing pinball, somebody turned the machine around, opened up the back, and brought out the chip that runs the pinball machine, and then just adjusted the numbers on who won. Which kind of practitioner do you want? And I don't care which one you pick. Which kind of practitioner do you want to train for? Do you want the expert user? If that's the case, you're going to get less change, less innovation on the battlefield. Do you want the expert tinkerer who can play with the back of that pinball machine? If that's the case, that's going to take a different kind of education process. It's going to take a different kind of training. You're going to look for a whole different set of people. Are we thinking about that when we think about future architectures? We need to be thinking also about which people are going to use those and what kinds of training do they need. You can't have them both. You can't have both they reordered the winners of the pinball game, by the way. You can't be both an expert pinball user and also really good at hacking, at least by my experience last weekend. My third point is, another unchallenged assumption is that the technologies will be implemented where they have the greatest effect. My bet, at least from the American example, is that we will automate first at the least important function that serves that particular culture of service. So you really want AI and automation to serve the Air Force by replacing the pilot. There is no greater fight than trying to take the pilot out of the cockpit in the US Air Force. So very quickly, the thing that you think, that capability that you're trying to develop for additional lethality is getting pushed down to, maybe we'll just adjust logistics. I'm not saying that's better or worse, but your ambition needs to work in conjunction with the culture that services identity, or you're going to get no traction at all. So what does that mean for innovation? That means that you're going to have to seek out those least loved MOSs, those occupational specialties within a service, and ask them if they want to automate. Because if it threatens the identity of the service, you're going to be met with a lot of resistance. And then my final unchallenged assumption when it comes to the implementation of all these machines is the notion that first adoption and lead users equals dominance. We learned that lesson from the Cold War as a nuclear and space racing analogy. First to the moon, first one to test this model of fission, first one to ICBM. That is not the time or the space that we're in intellectually. Right now, we are not in a theory building era, we are in an application era. So we all sort of understand how AI works, we all sort of understand some fundamentals of automation. Now the question is, can you create the use cases? Can you create the actual use cases that are going to get us on the ground and operating? So if you're going to think about that, what you want to think about is any place where that application can be most quickly, I don't want to, those are cheap answers. Like, we're showing you multi-million-dollar solutions. The best answers are the cheap ones right now in the current era. So if you've looked at all at Kai-Fu Lee's volume on AI in China, what he's talking about is that this is a race in which you're trying to take theoretical concepts that are already proven and just give me a use case. That is different. And that means, by the way, that everybody else is racing with us. We are not alone in this race. What you and I can do, what our services can do with an automated tank, a set of insurgents with a GPS, cell phone, and a couple cheap processors can probably do as well sufficiently. So this is a different kind of era. Being there first is not as important as doing it fast and in a broad spectrum. That's all I've got. Thank you.
Nina, thank you. I think you're in danger of coming out with a quote at the conference in that your ambition must work within your Army's culture. And I particularly like it. I know you use an Air Force and pilot analogy, but matching ambition with algorithms and technology to culture, I think, is key, and that's fantastic. And matching humans into AI, the paintball challenge, yeah. I would have smashed the paintball machine very early on, I'm sure.